Now here you have 4 different sources which are available, right? So design source, where you'll be finding all the source files are located. Constraint, okay, so what constraint means is, so when you write a source code, you have certain ports available in your design, right? Finally, you want to connect them to the actual hardware peripherals, right? So the mapping of your port to the hardware peripheral is handled by the constraint file, right? So we haven't specified this yet. Then the simulation source. So to verify your design, you would be applying a random stimulus to your design, okay? And that random stimulus generation is handled by a separate VHDL file, which we refer to as a test bench file, okay? So all the test bench file will be available in the simulation source. And when we perform a different process such as simulation, synthesis, implementations, all the information we'll be finding in this specific sources, that is utility source, right? So we'll just be going to a design source, double click on the source file, and now you could see with the input and output port specified, you get the template, right? So you do not need to do much in this template for a simple AND gate, okay? We'll be going through decoding each and every construct or a statement that is added over here right now, okay? We will simply be defining how our AND gate will work, right? So Y is an output port where you want to connect Y to A and B, right? So AND represent a logical operator, and the logical operator in the VHDL are as follows. So for an AND gate, you just need to mention A and D. For an OR gate, you just need to mention OR. For XOR, you have XOR. For XNOR, you have an XNOR and NOT, right? So this is how you represent the logical operators in an VHDL, right? The difference that you find between C and VHDL is, for a C, to assign a value to or an expression to a variable, you just use an equal operator, right? But in an VHDL, we have something referred to as an assignment operator, okay? So the second difference, right? So logical operator, if you remember C, they are like this. So for an ANDing, we have this, right? For an ORing, we have this, okay? For NOT operator, we have this, and so on and so forth, right? So in an VHDL, they are represented like this, right? And if you consider an way to assign a value or an expression to the output, so in a Verilog, we have this as an assignment operator, right? Whereas in a C, you simply use an equals to, right? These are the two differences that you'll be finding. So for us, output is Y, right? Then we need to use an assignment operator, and then input A and B, because we want to implement an AND gate, right? So this completes a code, and you also could be you also able to know how you represent the comment in an VHDL, right? So you add dash, 2 dash are mandatory to start adding a comment, right? So to add a comment, you just need to add 2 dash, and then you are ready to go to add comment, right? Now we do not have anything as a multi-line comment over here in VHDL, so we just need to use 2 dashes in each line, okay, to add the comment, right? So let us just go ahead and try to save our code, right? Another interesting feature that we get with an Vivado is, here you could see the status of your code, right? So if your code follow all the syntax correctly, okay, as mentioned in a language template, you will be finding a green option over here. This indicates that we have 0 errors, 0 warning, and 0 notes, right? So if you just try to commit a mistake, something like this is not identified in VHDL, right, as we used it in the C. So you could clearly see that here you get now a 3 errors, right? So this is an innovative way of understanding easily whether you are following a language template or not, right? So we'll just try to correct it. So here we have a T3 status, right? So green indicate that we do not have any errors or a warning. Red indicate that we do have a presence of some of an syntax error in our code. Now this doesn't detect logical error, right? But syntax error could be easily recognized by the red indication. And the third indication that we have is an yellow mark. So yellow indicate that you have some warnings present in a design, right? So this completes our step 1. We'll just save our code by pressing Ctrl and S. We'll be going back to Vivado, okay, and then we will save our design, right? So once you save your design, and here if you able to see a green mark, okay, that basically indicate that now you are ready to perform the next step, right? Something interesting you'll be finding over here is the 3 chips that you get just next to the name of your source file, right? So whatever name you give to a source file, that is the same name you get to an entity, right? Remember this, that is the same name you give to an entity, okay, and that is the same name you have over here, okay, when you explore the design source. And just next to it you will be finding the 3 chips, okay, that indicate that the source file where you have this 3 chip is the top module, okay. So entire flow navigator, so these are all the steps that we'll be performing. So this will be performed on the module where you have these 3 chips, right? So what we're gonna do is we'll just be trying to add a new source, and then we'll try to understand the usage of this, right? So let us just go ahead and try to add a source over here, okay. So to do that, you have multiple options. You could either click on this plus button or select the design source, right click, and there also you get an option to add a source, right? So we'll just be going ahead and clicking on this option. Now you get 3 options. So whether you want to add a simulation source, a constraint, or a design source. So we do want to add a design source. Click next. Again, you get the same window that we are getting when we are creating a project, right? So there, if you do not want, if you do not add a source file, once you are ready with a project directory and a project window, you could just click on this add source and you will get the same window over here, right? So let us just create a file. This will be naming as temp, okay, and then we'll be clicking OK and hit finish. Okay, here also let us just declare to input A, B, okay, and then output as C. Okay, we'll just be selecting this as an output. Now once you do this, okay, so now you find 2 sources are there, but only single source have this 3 chip pin assigned to it, right? This basically means when you perform the rest of the steps, this includes simulation, RTL analysis, synthesis, implementation, program, and debug. So all the steps will be performed on this source code, that is and_12. Okay, it will not be performed on temp. So if you want to perform all of this step on this source code, you could just right click. Okay, first you select the source code, right click, and then you just need to set it as stop. So once you set it as stop, now you could see that temp will have this notion, okay, assigned to it. That basically means all of this step will now be performed on a temp instead of and_12, right? So to delete the source file, process is very simple. You could just click delete on your keyboard or right click, and then you have remove file from project, right? You could also choose to delete the project from your directory, and this is the normal thing that we do. Okay, we'll just click OK. So as soon as you delete the file, the Vivado will automatically update an hierarchy, and then the rest of the module. Now here we have a single module, so you will be getting a notification whether Vivado should automatically pick up a top module, or you could just select this option and specify which module you want to set as top. Now here we only have a single module. We'll just allow Vivado to pick up the top module for us because we have a single module, so this will automatically be serving as the top module for us, right? So this completes the first step where we able to successfully create the source code. Now as we progress further, we'll be understanding step 2.